In the diagram, AB and BC are two chords of a circle with center O. AB equals to 6 cm, BC equals to 4 cm, and angle ABC equals to 90 degrees. So in this diagram, we have two chords AB and BC on this circle. The length of AB is 6 cm and BC is 4 cm, and this angle formed by the two chords ABC is a right angle. Part A, find the distances of the chords from the center O. Part B, find the radius of the circle. So referring to the diagram, we have to find the distances from each of the chords here from the center of the circle. And for part B, we have to find the radius of this circle. So to find the distance from the center to each of these chords, we'll first draw lines from the center to both chords. So we'll draw the perpendicular OM from O, the center, to the chord AB, as well as the perpendicular ON from O, the center, to the chord BC. And we'll also draw the radius OB of the circle, which will be this line, in order to find the radius for part B later on. So the diagram will look like this. OM will be the distance we need to find, which is perpendicular to the chord AB, and ON, which is the second distance that we need to find, will be perpendicular to BC. So since that OM is perpendicular to AB, OM will bisect AB, which means that the length of MB will be half that of the length of AB. This is due to the property that a perpendicular line from the center will bisect any chord. So AB equals to 6 cm, half of 6 will be 3 cm. MB will be 3 cm here. We'll do the same for this other chord. ON, which is perpendicular to BC, will bisect the chord BC. So NB will be half that of BC. BC is 4 cm, so half of 4 will be 2 cm. So MB here will be 2 cm. Now observe that for OMBN, we have three angles here, which are all right angles. So this last angle at vertex O will be a right angle as well. So OMBN will be a rectangle. So since that OMBN is a rectangle, OM will be equals to NB, which is 2 cm. ON, which will be then equals to MB, will be 3 cm. So hence, the distance of O, the center, to chord AB will be 2 cm, and the distance of O, the center, to chord BC will be 3 cm. Let's move on to part B. We are now to find the radius of this circle. The radius of this circle is indicated by this line OB. From part A, we have found the length of MB to be 3 cm and the length of OM to be 2 cm. So observe that for this right angle triangle OMB, we have the lengths of two sides of the triangle. We can apply the Pythagoras theorem to find the length of OB. Now since the side OB is opposite the right angle, OB will be the hypotenuse of this triangle. So by the Pythagoras theorem, OB square will be the sum of squares of the other two sides, MB square plus OM square. So substituting MB and OM with 3 and 2 respectively, we'll take square roots on both sides of the equation to find OB. So OB equals to the square root of 3 square plus 2 square. Evaluating the terms within the square root, OB will be equals to the square root of 13, which will give us 3.61. Correct to 3 significant figures. So hence, the radius of the circle will be 3.61 centimeters.